Module 4, Expressions, Linear Equations, and Linear Inequalities. This is section 4.8, Formulas and Problem Solving. In this video, we'll look at how to use formulas not only to find unknown values, but also how to rewrite formulas so that we don't have to solve equations, but instead just need to simplify. There's many different formulas in the world, and some you might recognize and some might be new to you depending on the field of study. These are some of the more common formulas. A formula takes a variable and defines it to represent a quantity. So A equals L times W is area of the rectangle is equal to length times width. I stands for interest, which is equal to PRT, which is principal times rate times time. There's perimeter of a triangle. Distance is equal to rate times time. And then also the volume of a rectangular solid, where L is length, W is width, and H is height. These are some of the more common ones. We're going to look at how to use these and also how to rewrite them. If we wanted to use a formula to find an unknown quantity, like Charles, who has enough fencing to close in 140 feet of an area and knows that he wants the width of the garden to be 30 feet, but needs to figure out what the length should be in order to create an area that fences in just the amount that he needs. So he knows he needs something like this, and we want the width to be 30. But we don't know this. How big or how long does the length need to be so that when I add these all up, it equals the 140 foot of fencing that I have? Well, the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. Well, I have the perimeter. I know it's 140, so I'll sub that in for P. And I know I want the width to be 30, and that's W. After I sub in these values, I can begin to solve for L. 2 times 30 is 60. But I want to isolate L, so I'm going to subtract that on both sides. 140 minus 60 is 80. And of course, 60 minus the 60 will give us our additive identity of 0. Now I could divide both sides by 2, and I find that I need the length to be 40. 40 plus 40 plus 30 plus 30 will give me 140. If I have a flower bed that's the shape of a triangle, and I want one side to be twice the length of the shortest side, so let's say I have something that looks like this. I have the shortest side, and I want one side to be the twice that, and I want my third side to be 30 feet more than the shortest. Well, 30 feet more than means to add, so take whatever your shortest is and add 30. Now, I still don't know what the shortest side is, so that's going to have to stay in X or whatever your favorite variable is. But double that is 2 times whatever your favorite variable is, and then 30 longer than the shortest side would have to be plus 30. Well, we know to find the perimeter, we have to add up all the sides. When we add up A, B, and C, our shortest, our second shortest, and our longest, we're still going to be left with variables, but it will be a little bit neater. I know I have 102 for a perimeter. A, well, one side is an X, another side is a 2X, and my third side is X plus 30. I have like terms. X plus 2X plus another X is 4X. And now I can solve this equation. Subtract 30 from both sides. 102 minus 30 is going to be 72. Divide both sides by 4, and my shortest side, which was X, has to be 18. I can now use that X and fill in the other sides. If the shortest side is 18, twice that is 36, and 30 more than that is 48. So now I know the sides of my garden. I need it to be 18, 36, and 48. If I want to rewrite a formula, and sometimes if you're looking up extra information about these, they might be called literals, we're going to leave all the variables in, but we're going to scramble the variables up. We're going to move them around as if they were numbers. You may have to multiply on both sides to get rid of fractions. You may have to distribute, or you may have to factor. you may have to then combine like terms. The last thing that you're most likely going to have to do is use the multiplication property and divide something by both sides. Sometimes the shorter ones are the trickiest. T is equal to m times n times r. Solve for n. These are all linked through multiplication, but you don't want to divide and then divide again. But conveniently, multiplication is commutative. So instead of saying m times n times r, I can say m times r times n. I could just move that out of my way. And think about this mr as the coefficient of n. So instead of dividing by m and then dividing by r, I can divide by both at the same time. Anything over itself is 1, so I'm only left with an n over here. And now I've rewritten my formula to solve for n, so it's n equals and not t equals, and n is equal to t divided by mr. If I have a is equal to p plus prt and I want to solve for t, think about all of these other ones as being numbers. Even the a. Let's say that a is 5, and let's make this a 2, and instead of PR, let's say it's 25t. If I were going to solve that, I would start with a 2 and subtract that off on both sides. But I don't have a 2, I have a p. So I'm going to subtract p on both sides and get a minus p, and I'm left with PRT. If I was over here, I know that would go, but let's not combine these. Let's leave that as 5 minus 2, even though we know that's 3. And that's be equal to 25t. Well, now it would divide by 25 on both sides. But I don't have a 25. I got a PR. So I'll divide that on both sides. And now I've rewritten the formula so it says t equals, but it's a minus p up on the top and pr down on the denominator. This can get a little bit more tricky if I wanted to solve for p. If I wanted to solve for p, because there's 2 of them, I'm going to need to factor that back out. I'm going to like undistribute. Right? Because if I had p times 1, that would give me p, and p times rt, well, that would give me prt. Now I want p by itself. Now, all of this is being multiplied by that. So we could do that flip again, where I can think about all of that as the coefficient of p. So all I need to do is divide by 1 plus rt on both sides. When you have the variable that you want to solve for appears more than once, you're going to have to factor someone along the way. Let's look at one more. I'm going to go back a slide so I have some space to write. Let's say I wanted to take my perimeter formula from before. Perimeter is equal to 2L plus 2W. And I want to solve for W. That's this one right here. If you imagine everybody else being a number, let's say 5 is equal to 21 plus 2W, you would subtract this first. Well, it's not a 2, 1, it's a 2L. So let's subtract 2L. And I got P minus 2L is equal to 2W. If you had subtracted the 21, it would be 5 minus 21 is equal to 2W, and you'd have to divide everybody by 2. Now, of course, with numbers, you would say, well, 5 minus 21 is a negative 16, but you can't make P and L Q, or whatever other favorite letter you want to pick, so we'll just have to leave it like that. So now that's what I'm going to do here. You can divide each individually, or you could just do one big one. And this rewritten for W would be P minus 2L over 2 is equal to W. And that's how you rewrite formulas.